So before, this is still warm up. Everyone's like expecting me to. We'll start in a minute or two. Once everyone finds their seats. On a bunch of Slack groups, I announced that we're going to do a live stream. But this is like the first time that like we literally are doing a live stream. So we didn't announce it too widely because we're thinking we don't know if it's going to work super well. But my wife Irina is a live stream master. So I mean, so far it's looking good. All depends on the internet. Okay, there we go. Okay. We're streaming out into the ether, into the void, onto the internet, onto YouTube. That's the correct answer. Sorry, I gave like 2 jerk answers before I gave the actual thing you were looking for. All right, I think we're good.
Outlier government agency kind of Viz and DOD that
Okay.
Well, of course, they did a lot of, I think, intelligence.
So welcome everyone. I'm going to explain what's going on, why are we here. The short answer is we're here to celebrate the Dec's New Year. Okay, it will be midnight at 7 p.m. in exactly half an hour. It will be midnight in London. You can call it Greenwich Mean Time. You can call it UTC 0, or you can call it, the proper term, which is what that uses, which is Zone 0. So in Zone 0, it will be midnight in half an hour. Okay, and we're celebrating according to the Zone 0 time, so we don't have to stay here until midnight. Okay, we'll enjoy some sparkling cider and some prosecco. You can also take food to go and go back to your loved ones. We won't be here for the whole night, right? But in about half an hour, we're going to kind of have a ceremonial toast for the Dec's New Year. How many times in history has the Dec's New Year been celebrated? Well, 0 times so far. So I mean, like, this is now the first time, you could say, right? So this is celebration 0. We're at ground 0, time 0, everything's starting now, right? Okay, so the title of the presentation is Dates and Times in Data Science. You can tell I had to lean in and look. I'm like, what am I talking about? This is, Jeff and I were talking about what do we have as a title for the presentation, right? We wanted something serious, and there will be serious things in here. What I want is for it to be kind of light and fun, and there will be opportunities for interaction, and there's going to be some hopefully kind of like a lively atmosphere. That's what we're going for, okay? All right, so let's get started. So Jeff, maybe, should I do this or should you do this?
I can do it.
You can do it? Maybe let's bring Jeff up.
I've
Jeff,
done it.
You do this like you do this twice a month.
Not always. We have lots of folks here on the team who also do it, but sometimes I've done it a few times. Oh, I guess I should start by saying what we are. Data Community DC. Who's heard of Data Community DC before? All right, cool. Well, you are all here at Data Science DC / Data Viz DC meetup. We are both under the umbrella of Data Community DC. So Data Community DC is a nonprofit that takes care of all those kind of administrative things for us, and there's a whole bunch of different meetups under that group, including Data Engineers DC, recently came back into being. So anybody at that recent Data Engineers DC meetup? Sweet, it was right here. There's another one coming up soon. So check out the meetup group if you're not already subscribed to that. You see all the groups there that are pretty active. Encourage you to go to dc2.org. You can use your little QR code scanner there if you want, and see what meetups are happening around town. I'll give it a pause because I see at least one phone. Yes, good work. All right. So the Data Community DC board members are listed here, and advisory council members also. So if you have something you want to talk to about what's going on, talk to any of those folks. Maybe put a hand up if you're one of those people here, just so people know who you are. Yeah, Abigail, Will, cool. Yeah, nice. Okay, cool. Thanks. Data Science DC has a few organizers: Abigail and Prima and did I see Ben? I didn't see Ben tonight, I don't think, but Prima and Abigail, want to put your hands up. So we're Data Science DC organizers. Come talk to us if you want to. Connect with us on all the social things. the Data Viz DC organizers. Will is here, Jamal is here, Alex is here. Did I see Jill? I didn't see Jill, I don't think, but I saw some hands there. So talk to those folks if you want to talk about Data Viz things. Yeah. So Prefect is the food and space sponsor. I also work for Prefect. We do workflow automation. If you have Airflow, I'm sorry, we're an Airflow competitor and try to make life better. So come talk to me if you want to talk about those things. We do have a diversity statement and a code of conduct. You can scan for the code of conduct there. Basically, we want to make sure that we have a good diverse group of speakers and that it reflects our community. So that's that. Code of conduct boils down to be nice to folks. If you see anything that isn't in accordance with that, reach out to one of those people who put their hands up earlier. DC2 Slack, if you want to keep the conversation going after this, there's a QR code for that, or just go to bit-ly/DC2 Slack and join one of the channels there that is of interest to you. If you want to speak at a Data Science DC meetup, it's another QR code. Check it out and fill out the form there, and someday somebody will get back to you if you're lucky. No promises on how soon. But we will. That reminds me, we'll do that soon. Prima Abigail, hold us to it. Let's have a little organizing meeting soon. We got some upcoming events here. Power BI DC has a Career and Community Support Day happening March 1st, which is tomorrow, at Excella, I believe, right? So this is especially targeted for those in the community who are looking for career and community support. Obviously, there's lots of folks in that boat with the current situation. So encourage you to go there and find some support and work together on that. Cool. Is anyone here with that who wants to say anything about it? Beyond that? Yeah, Will?
So Leslie Welch, who's organizing that, is not here tonight, but maybe joining us on the live stream in the future. But that's going to be a sort of career and community support day. So if you need help with your resume, need help finding a job, need some emotional support, or know someone who is in that situation.
Science DC meetup from the snowstorm. Hard to believe, but it wasn't that long ago that we had a really big snowstorm and we had to cancel the event. So that is rescheduled for March 11th right here. Check that out. And you can see what's going on with the dates there, right? There's something going on. I won't say anything else about it. But thanks everyone for attending and being part of our community. And that's the last slide.
Yeah, you can flip to the next one.
Okay.
Yeah, because it's back to where we started. You see, this is the transition slide.
Whoa! Yeah. So the presentation starts now. Okay. All right. So thanks so much, Jeff. So this is the agenda slide. This is one of those things that was drilled into me during my 12 years of graduate school, is that you're supposed to first tell people what you're going to tell them before you tell them what you're going to tell them. And then once you're done with that, you have to tell them what you told them. Right? So that's, we've got a lot of things. We may have to kind of skip to the demo over a couple things, but we're going to start off with an intro. An introduction to the speaker. There's some speaker info, and that's me. So I'm going to introduce myself. Then we're going to do a survey. So I have a background in many things, but one of those things is epidemiology and biostatistics and survey analysis. And you're always supposed to do, in education, you're supposed to do a pre-test and a post-test. So that's kind of in that vein. It's also inspired by Will, who used Mentimeter is the tool we're going to use for the survey very effectively. I thought it was really great at the latest Data Viz DC meetup. Okay, I'll show you a date algorithm. All right. If you don't know what an algorithm is, it's basically a function. It takes an input, gives an output, or it does some things along the way. We'll do some maybe limited Viz and Tell, which is a data viz thing. It's like show and tell except with data visualization. I have some props, okay, which are physical objects that I'll use to try to explain concepts. All right. We'll do a demo, and there will be a place you can go, maybe on your phone, and you can look at the code live, running live on your phone, or if you have a laptop, you can also do that. Yeah. We'll do a toast, an official toast to the new year, and that will be in 20 minutes. So you can see I'm gonna have to motor through the agenda a little bit. We'll do questions and then also announcements. If you haven't been to one of these meetups before, Usually there's community announcements. People announce events that they're planning or organizing or excited about. Jobs, if they're looking for jobs or if they're looking to hire people, we'll have that at the end. At the very, very end of all of this, eventually, we're gonna organize a group of people to head to Tonic for data drinks, which is another time-honored data community DC tradition. Is to go just around the corner, really, and then it's a place where you can purchase. If you haven't had enough alcohol, you can purchase alcohol there. But that's a great place to kind of chat, continue the conversation after we finish the presentation here. Okay. All right. So a couple of things on here. If it's hard to see, don't worry. We're going to kind of zoom in and talk about all these individual pieces later. This is kind of just to put some visualizations up. Okay. So this is the intro to me. My name is Martin. You don't have to worry about how to say my middle name, or my last name actually now is thanks to my wife, is a lot easier than it used to be. But Martin Laptev, okay? I have a bunch of degrees. I have a PhD from Georgetown University, an MPH from Johns Hopkins University, Masters of Science from Jagiellonian University in Krakow, Poland, and for undergrad I went to St. Mary's College of Maryland. Okay, I speak several languages, and then the ones that I put up here you can hold me to, so that if you go up and say like, oh, you speak French, okay, let's try. Then you can test me. There are oh, go ahead.
You don't have English listed there.
I don't speak English. I didn't know what flag to put, okay, because it's a little bit controversial there, right? If you put the American flag, anyone who's British says, hey, you know what we came up with? Okay, that language. Anyway, so for coding, in terms of coding, I think it's always nice to know, I ask these questions like, what's your name when I'm meeting people? What's your name? Where are you from? What language do you speak? What language do you code in, right? And that's kind of how I try to identify with people, connect with people. I always like to tell people is that I am very into Haitian music from Haiti, which is, there's an island in the Caribbean which is called Española. Part of it is the Dominican Republic, and the other part is Haiti. Actually, from your perspective, it'd be like this. And then Haiti is the country of origin for music genres called zouk and compa, and these are, very excited about these. I think they're the best, hands down. But I have a lot of, very broad music taste. But these are clearly for me the number one music genres. Okay. So that's about me. All right. We're ready to move on to the survey. Okay. So we need your participation in the survey. Okay. If we have just one or two answers, it's not going to work, right? So what you can do is you can scan the QR code, or if you prefer, you can go to menti.com, okay, and then put in that code, 17. This is a survey created. I'm going to switch over to that right now. So hopefully everyone who needed the QR code got the QR code. Okay. And then, does someone get the reference here for the GIF or the GIF or however you pronounce it?
Monty Python.
Monty Python. Quest for the Holy Grail. That's right. And then down here, there was like a internet thing where people were going crazy about what color the dress is. Okay, so it's a dated joke. All right, let's switch over to this one. I hit present. It's loading. The internet connection maybe here is, oh, that looks good. Oh, I should have shown this, right? The QR code would have been much better. All right, so if I, oh, people are already answering. If I have a question about the survey, I know who to ask. All right, so this first question.
One of my primary languages is not on there.
Oh, oh, sorry, I will explain that, but let's focus on this here first, right? So this is where you're from, right? Let's close this little guy, and then first I'll explain kind of this map. So this map is a little bit different than how you might normally look at the world, right? So here, this is, if you've seen this, this is a map that is centered maybe around 162 degrees west or whatever, but this is how you see the world according to the system that I'm trying to promote, which is called maybe like DES, which is short for decimal, for everything to be basically decimal based, base 10, instead of base 12, 24, 60, 360, having everything be based off of 10, okay? So here we have these, let's say, kind of like 10 time zones, which are 0 through 9, and we have meridian, which is this kind of a vertical, 0 here, all the way through meridian 9, all right? We got a lot of people here in the US, some people on the, looks like on the West Coast, most on the East Coast. Someone put very, very high up in Canada. That's really interesting. Someone chose an island, I think that's right on the edge of the map. Another person put Antarctica. I'm starting to doubt the veracity of some of these responses. I don't know, but I'm, okay. Someone was born, I'd say, around Gibraltar, which is cool. South Africa, that's what I think. I was born here, I guess I haven't taken the survey yet, here in Poland. All right, good. So now I think we're ready to move on to the next one. Let's close this as well. Okay, so this one, to explain, these are I guess the results live is what we're seeing. So we had to pick the top 30. If one of your languages is not on there, I do apologize, but if it makes you feel any better, one of my languages is not on there. Polish didn't make the cut. It's not in the top 30. And this was, and I tried to find some way to get Polish on there. It's a hard limit, okay? So of course English is good. If you're wondering about how this is working, this is ranked choice voting. So this is basically how I think democracy should work just in general. So that you don't just put, oh, I know English, I feel most comfortable in English, and that's it. You rank the languages, right? So I see Spanish is a number 2. We have then Chinese, oh, that's great. French, German, Russian. I would say English and Polish, then Russian or Spanish, and then French would be my my order. Okay. All right. I think we're ready to move on here. Really cool. Awesome. Okay. So this is, what programming language do you feel most comfortable using? Right. And I try to make these questions to be clear. Here we're also doing ranked choice voting. Right? So it isn't, oh, I use Python and then that's it, and we don't get any further information from you. I am a polyglot in terms of natural languages and also programming languages. So I think it's nice to be able to say, oh, I use Python. Yes, that's probably the language I feel most comfortable in. But I'm also great at JavaScript, and then I'm also great at R, and then maybe, I'm not bad at a few of these others, right? And I think that's useful information, okay? So at the top, we've got Python. Number 2 is R, which is great. Here we picked the top 14 languages on the Stack Overflow survey from 2024. So we're trying to be objective here in what languages we include, okay? All right, Java's a big one, JavaScript, and then C. Well, that's great, because that's kind of what's coming next, okay? All right, cool. So this question is, what is the result of running date.now in a JavaScript console? Okay, we've got some people who know JavaScript. If you know, that's great. If you don't know, that's fine. It's fine to guess. One of the things I can try to do, this is maybe a little bit risky, is to apologize. Try to open up a console. No, that didn't work. Okay, so open up, go to console here, clear the console, and then this is going to be super small, but I'm going to write date.now in the console, and there's the result. Okay. So if you have a computer handy, you can always just access the JavaScript, right? So date.now, it gives you an integer, right? And then if you do just date, right, it gives you a string. Friday, Feb 28, 2025, 18:50:09 GMT -05:00 Eastern Standard Time. It's a lot of information, right? And a very long string. Okay. All right. So the correct answer here, I'm going to show the correct answer. This is the first time where there is a correct answer. Okay. The correct answer is milliseconds. Okay. So date.now in JavaScript, when you call that method, that function, it gives you milliseconds. So it's the time since, okay, you know, and that kind of thing makes it so that ordinal dates are useless. Right? In this system, DES, day 300 is always day 300. Doesn't matter whether it's a common year or a leap year, and it translates directly to the Gregorian calendar. Right? So I can tell you that you know, if you give me a date in the Gregorian calendar, I'll be able to translate it into day of the year, and vice versa. And we're going to do that in a second. Yeah. The leap year rule. Okay, there was a question about the leap year rule. Now that we're past the toast and we all yelled Happy New Year, right? I can answer that question. So with the leap year rule, it's essentially exactly the same as the leap year rule in the Gregorian calendar, okay? Except you add 1 to the year, okay? So if 2024 is a leap year in the Gregorian calendar, 2023 is a leap year in DES, okay? Why is that? It's again this thing of where is the leap year? Where's the leap day, right? In DES, the leap day is the last day of the year, okay? Not day 60, right? Which is how it is in the Gregorian calendar. All right. Yeah, question?
On leap years is are the beats, so the beats they're always the same amount of time.
Yeah, exactly. And so the breakdown is that, does anyone know how many seconds there are in a day?
86,400.
That's correct. Everyone who said that, you're all correct. Okay, 86,400, and that's a little bit random. Seems like, you know, kind of. It's the reason for it is so that it's evenly divisible, right? Which now that we have computers and we can handle things like decimals, right? It's not so much of a big deal, I think, anymore, right? We don't have to stick to things that are base, you know, 6 and 12 and 24 and 60 and 360. Okay, a beat is always a beat, right? All the time, everywhere. It's 1/100th of a day, which is 0.864 seconds, or you can say 864 milliseconds, right? So it's a little bit short of a millisecond, but it's actually kind of, I think, closer to what you might think of as a normal heartbeat or a musical beat. If you think of 60 beats per second, right? 60 beats per minute. That's a little slow, right? Yeah. So I mean, like, if you think of a song, like 70 is closer to what you might consider a normal heartbeat, a normal beat in music. Okay? But it's basically a second. Okay, 1/100th of a day, a centimille a day, or a beat is basically a second. Okay. The other thing, Will was talking about millidays, right? That's 1,000th of a day. That's basically a minute. It's closer to a minute and a half, but you can think of it as a minute. The next one over, right? Let's say the second digit after the decimal is a cent a day. That's about 15 minutes. That's pretty useful, right? So if you think of an hour, that's going to be 4 cents a day, more or less. Okay. All right. Any other questions? I think we're doing questions now. So.
Yeah. This is one's really rudimentary.
Yeah.
But when we were doing the New Year's, it was counting down.
Yeah.
And now it's counting up. Did you reset?
That's so good. That's so good. The countdown, after it passes 0, automatically, naturally, becomes the count up. Have you ever seen a NASA launch?
Yeah.
Yeah. The countdown, the negative, they say T minus 4, 3, 2, 1, 0, and it launches, and then it keeps counting, and then it becomes +1, +2, +3. So that's a natural and normal thing, right? Which we can't really take advantage of if we're splitting up time into hours, minutes, and seconds, and milliseconds, and whatever other nonsense, right? But here it's just a natural part of the system, right? And so right now, when I showed you kind of the future, right? 2025 and 2026, all right? They were both negative. Now we're already in 2025, so this one's positive, but this one's negative. And next year we're gonna go through the same exact thing. Hopefully here, I already checked, it's gonna be a Saturday, so I hope that works for you all, okay? And you know, if, yeah, or maybe Excella, because Jeff was thinking after all this work for this, you know, it's like, we may want to go to Excella. Okay, I get it, okay. And then if we look forward kind of still further, both of these are negative, but eventually they'll be positive when we get there. Yeah.
So for any given time point,
Yeah.
you could have two characterizations.
Sure, I can have lots of characters.
It's going up or it's going down.
All of these are actually the current time.
Right,
right?
exactly.
It's just a different way of showing it. If I go back now to 2023 and 2024, you see both of these are positive.
Right,
Yeah.
so it's reference points you
Yeah.
set.
It's different reference points, exactly, but they all show the current time.
Relative to the current time.
Exactly. Perfect. Excellent. Yeah.
So in the metric system, the second is the unit of time. You chose a day.
Brilliant. Great question. Okay, so the question was there about, you know, in the metric system or SI, which is scientifique international, the base unit of time is a second, okay? But we went with day, all right? Seconds are great, you know, not trying to throw any shade on seconds, but they're not base 10. In this system, everything is base 10. So instead of saying that, you know, how many seconds are there in a day, 86,400, we say 100,000. Okay, everything's base 10. 10 to the minus 5, that's a beat. Okay, this is a different system. We're replacing much more than just seconds. Okay, this is getting like way ahead of me. I won't have time to talk about it. We're replacing also meters. So if you dislike meters, you know. We've got something better. Okay, maybe let's do what I don't know what your name is in the brown jacket.
My name's Evan.
Evan.
So I'm just curious, like, you know, the regular calendar, it's like the seasons. You can really tell
Sure.
what seasons are.
Sure. Great. Yeah. Perfect. So this is really in line with like meteorological seasons. Okay, which spring starts March 1st, which, you know, you could kind of say like in London. Of London time, it is now spring according to the meteorological record. Okay, so that's perfect. When will be the next season? Add 90. Okay, when will be the season after that? We'll add 90 again, and you've got 180. Okay, add 90 again, and you've got 270. Right, and so those are the seasons. I think it's more intuitive than having to think like, oh, it's 3 months. How many days is that? Oh, it's hard to say, right? Oh, sorry. Will was next. I'll get you after. Okay? Is that okay?
So you said, you know, no disrespect to seconds. How do you deal with unscheduled leap seconds?
Oh, sure. In this system, well, this is like a personal thing, but this is based off of Unix time, right? So that's what we were talking about. JavaScript shows it in milliseconds. Other systems may show it just in seconds. But those are the seconds until since the Unix epoch, and I'll talk about exactly what that moment is in a second, but without leap seconds. So Unix time doesn't have, so if we base off of Unix time, there's no such thing as leap seconds, okay? So if we want to translate into a certain time that contains leap seconds, we can do that, but this system doesn't. And personally, I think leap seconds are just a bad idea, right? We shouldn't do that, and I think I'm not alone. And certainly that's a great discussion we can have at Data Drinks at Tonic afterwards, right? You were next, yeah?
Yeah, I'm thinking about the slippage between the calendar season and the meteorological season.
Oh.
That you have a 360-day year,
Oh.
and you know that's not unprecedented. The Egyptians had a 360-day year
It's
plus intercalary days to make up for the difference.
just a quick note. It's 364 in a common year and 365 in a leap year. It's the exact same as in the Gregorian calendar.
Yeah, index 0.
Yeah, you're right.
Yeah, good. You know, and I've been.
Oh, sorry, I
I've
said
been-
it wrong. It's 365 in a common year, 366 in a leap year.
Okay,
Sorry.
But if you're defining a season as 90 days,
Oh, that, that's like a ballpark thing. Just like the meteorological reckoning. There is the astronomical reckoning, which is the official, a season is not exactly 90 days. And it's not exactly 3 months. And so those are ways that we're approximating the astronomical reckoning, which is the official thing. But that's very hard because every season has a different number of days. It's about 90, but can be 92, 93, 94, depends on the season.
you know, I'm used to the Persian calendar by now,
Oh.
in which the on the 20th will be known as the
Perfect,
first
perfect.
day of the new
Great.
year.
Great.
At
So
about 12:30 hours sometimes.
excellent, excellent. So the
It's-
gentleman mentioned the Persian calendar, right? Which is, I think, if we're not talking about the Gregorian calendar, so just set that aside. Definitely, that's the best calendar. Okay. And if we include the Gregorian calendar, I'm like, it still is kind of the best calendar. But then maybe that's open to debate. The great thing about the Persian calendar, right, which you can also call the solar Hijri calendar, is it starts on astronomical spring, okay? The spring equinox, right? Or the northward equinox in the northern hemisphere. When that programmed in here, but
You don't, systemically, you can go either up or down for the next beat. And so how is that anchored? It seems to me as a clock
Sure,
system
sure.
and an automated system,
Yeah.
that could go way bad.
well, it's based off of Unix time, and Unix time only goes in one direction.
Okay,
It
so
goes by
that's
seconds.
unit direction.
And these are just different ways to display
Okay.
that central kind of
So it's
understanding of time.
secondary. It's
Okay.
secondary to the fundamental.
Exactly.
unit
The
direction.
fundamental is how computers tell time. And then what I'm proposing is, so the fundamental units here are day, which is the Earth rotating one time on its axis. Okay, that's a day. And then there's a year, which is the Earth rotating once around the sun. Okay. In terms of distance, we were almost there with a meter. Okay. What they decided to do with a meter was you go from the equator, right, up to the North Pole, and you pass through Paris because, of course, these were the French who were defining it at the time in the late 1800s. And this thing is called a quarter meridian, right, or quarter meridian arc. Okay, this distance, and that is defined as exactly 10,000 kilometers. Okay, so note that it's kilometers. It's 10 million meters. That's how they define it. Even though the definition now has changed, it's based off of how far light goes in a very, very short amount of time. Okay, even though the definition has changed, this distance is still basically 10,000 kilometers. Right? It's off by maybe like 7 kilometers. Right? So it's still incredibly close. Right? So instead of doing like a quarter of the way around the world, in this system, tau r. If you know the formula for circumference, it's c equals 2 pi, which is tau, r. Right? So whatever you call it, we've got that circumference, and that's what we base everything off of. Yeah.
Well, how do you account for the variable circumference?
We standardize it. Again, just like how this is standardized to Unix time, which is a very specific thing. We standardize the circumference of the world, and I apologize if it's a little bit off. Depends on which way you go it's either a little bit too small or a little bit more too small. But we go, it's 40,000 kilometers. That's what C equals, okay? All right? And so that's how we have our main unit, okay? Which we can easily translate into meters, right? That's how we do distance. Now, my next prop is a tape measure. So the circumference of the world is very big, as you can imagine. So we need something smaller, all right? So what that uses is, it has a thing which is called a zem, okay? Which is I should have a world map here, but you can just listen to my words and hopefully this makes sense. But it's a zone equatorial meter, all right? So at the equator, we've got 40,000 kilometers, all right? That's split into 10 time zones, okay? And so now we've got 4,000 kilometers, okay? And so that's, and then we basically get a meter from that, a zone equatorial meter, okay? When you get 40 centimeters, okay? So this is it, okay? What is this? This is basically 4/3 of a foot, okay? It's exactly 40 centimeters, and this is the unit of distance, okay? Some things that maybe are a little bit noteworthy is that this is a unit that works basically like feet. Most people are going to be between 4 and 5 zem tall. And if we look at Vitruvian, I'm going to pass this around. The Vitruvian Man, who knows about that? Yeah? Leonardo da Vinci drew this. I'm a little bit taller than 4 zem, which kind of messes it up. But the idea is that a zem is going to be more or less this distance, right? From my ankle to my knee, right? From my knee to my hip, from my hip to, let's say, my armpit, from my hand to my elbow, right? It's something that's just happens to be. It's a little bit of a coincidence, but it fits so well with the human body, okay? If everyone's okay with cartoon nudity, I'm going to pass this around. The Vitruvian Man by Leonardo da Vinci, okay? In the slide, I have him censored. But the way that he's censored almost looks worse than. All right, okay. Let's switch back to the slides, from the demo back to the slides, because I think that's going to help us with the questions. Okay. All right. So, and I will continue to take questions. Okay. Once this turns on. So, Alex, you had a question?
Well, just so you were talking about zems.
Yeah.
And zones. So
Yeah.
I guess that means that you also have a different definition for time zones.
Oh, sure. Yeah. Let's talk
That's
about
the
that.
application.
Let's look at this map here. Okay. Essentially, what we do is we split up the world into 10 time zones. All right. And each of these is one deci, let's say, circumference apart, and it's also one deciday apart. Right. These are based off of longitude, and longitude and time, if you think about it, are kind of synonymous, right? One rotation of the world on its axis is 1 day, and if we move from one spot all the way around the world to the other, that's one circumference, right? So it really is a nice, simple system where everything is based off of 10, and everything translates to things that kind of make sense to us, right? The length of a day, 24 hours if you prefer, but okay. And then here, these 10 zones, which are one deciday or one, let's say, circumference wide. Okay?
But wait, sorry. It makes sense because it's flat, but it's not actually flat.
Sure.
Right? You get weird.
It works as a globe. Yeah, absolutely. There's curvature to it, and that actually takes me to my first Viz and Tell. If we're okay with that. All right. So let's do. Let's open up the link. Get it loading, and then I'll show you really quick the Viz and Tell slide. It's the first link in the Viz and Tell slide. All right, it's loading. While it's loading, we'll give it a second. I'll see when it loads. Oh, there it is.
Give it a second.
Ah, yeah. See, that's the thing. All right, good. So this is the world without these time zone lines, but I can add them in. So it's based off of a grid because there's also these parallels or lines of latitude. Okay, but basically we've got which time zone are we in? We're right here. This is zone 8. All right, or if you prefer, zone -1. Okay, it's basically the same thing. The power of 0. Okay. And in this is the Viz and Tell. I can show you how, as I move these points around, the longitude, which is measured in milliparallels or thousands of kind of loops around, let's say the equator or whatever at whatever latitude we are, right? That's the first number. Then the second number is millimeridians. That's how we measure latitude. Again, a meridian is a vertical line on the map, right? And that's thousands of a meridian. And then the last thing is bearing or azimuth or whatever you want to say, what the orientation, direction, whatever you see on a compass, yeah? And that's in milli-windroses. Don't worry about the units. These are clever. They're good names, I promise. Yeah, Alex?
No,
Sorry.
no, I just.
Okay, sure. Oh, thanks. So what I'm going to do now is, okay. And I'm gonna pick a projection here. Okay. I'm gonna pick a projection, right, and show you how. And this is a little bit crazy. If you're unfamiliar with map projections, there are different ways of taking a round thing, which is our planet, our globe, right, and putting it onto a flat thing, like a screen, okay? So parallels are, well, they're parallel and they're straight lines, but meridians are curved, okay? But everything still works, yeah? And then what time zone is which here? Basically what you do is you take the longitude, right, in days or parallels or circumferences, whatever you want to call it, right, or tenths of a circumference, and you floor it. You floor it means you get rid of the fractional part. You're left with an integer. That's the zone. So very simple definition of a time zone. Okay, and I have lots of projections loaded in here, probably too many. This is one which shows you a little bit of that. This is us showing a round thing on a flat surface. Okay. All right. So that's my first Viz and Tell. I can hit reset and everything pops back the way it was. I can also show you the grid, which is how Dec looks at the world, and I can show you UTC time zones, which are a complex, difficult mess. Yes.
So with the, can you geographically very close to somebody in a very different time zone because of how it curves?
Oh,
right?
sure. Well, very few people live up here, right? Okay. But certainly if you were in the North Pole, you could say, I'm in one time zone. I'm in another time zone. But that's even more the case with UTC time zones, right? Because does anyone know how many whole hour UTC time zones there are? There are 26. Why are there 26 if there are 24 hours in the day? Someone decided that. And then you can also have half-hour time zones and 15-minute time zones and 45-minute time zones. Do you know the time zone for Tehran? Yeah, that's an example. So it's 3.5 hours away from UTC. Okay. So here I'll show you. UTC would be here. You can say UTC, Greenwich Mean Time, right? And 3.5 hours east, that would be Tehran. Okay. But I think that's a little bit, a little bit complex, right? Where we say, how many time zones do we have? Well, no one really knows, right? Here we have 10. And if someone doesn't like the time zone that they're in, sure, just tell people, hey, I'm actually in zone 3, right? Or I'm working on based off of zone 5. And we can communicate because it's all single-digit operations, right, for translating the time zones. If you're 2 time zones away from me, I changed the first digit after the decimal, I would add 2 to it or subtract 2. It's pretty easy in terms of just doing these mental calculations. Okay? All right. Yeah, another question.
Question.
Yeah, go ahead.
Yeah, so I think you keep emphasizing simplicity of this.
Yeah.
But isn't it the other way? Now with computers, do we need simplicity? Like they can calculate. I never had an issue with this. So
Sure.
the question is, wouldn't it be more appropriate, I don't know, 1,000 years ago when the people didn't have computers?
No.
But today it doesn't matter.
Well,
They say that.
it was tried during the French Revolution, or something similar to this. I think this has a number of advantages over the French Revolutionary calendar and time system. But I think it's always better to at least give people the option to use something that's simpler, right? I think it's, working on like date algorithms, I always thought it was kind of silly, like, why are we binning these things into these ever smaller kind of bins, putting things into these ever smaller boxes? Sure, 1,000 years ago when we were, let's say, maybe using sundials and water clocks. Sundial you can use during the day, and a water clock you have to use, well, when there's no sun out, right? But here, how it would work is you've got a water container for year, right? So every year it goes up 1 notch. And then when it goes up to that notch, it would fill in the day container for water, if you're familiar with how a water clock works. That's pretty simple. We could build it. It's also simple to understand. It's easy to parse with our human eyes and understand with our human brains. If you wanted to build a water clock based off of years, months, days of the months, hours, minutes, and seconds, it would be some kind of contraption that would fill this room, and it would be very complex. What I want to say is, I think this is better, but I want to have room in the world for people who disagree with me, okay? Which is most of the population of the world probably, right? Considering that the people who know about this system are in this room right now, So certainly I want to meet people where they are, and if we want to show time a different way, we can certainly try to do that, yeah? So your hand first, and I'm going to go with you. Oh, no, sorry. Yeah, let's go with you first.
So one of the reasons there's so many different time zones is because of geography.
Yeah, exactly.
How does that come into play with, like, if one of the time zones is in, like, the middle of the city,
Sure.
Is there room in your...
Well, the city can decide, the government can decide that we're not in this time zone. A great example, let me zoom in on Iceland, right? Okay, so I've been to Iceland, okay, for my second year anniversary? Yeah, wedding anniversary, right? We were in Reykjavik, okay, which would be in time zone 9, okay, or -1. So, first year anniversary. It's the nerves, it's the jitters. So we're in Iceland, but then when we went to the east part of the island, we were suddenly in a different time zone. That doesn't make any sense, right? I think it's fine for the country of Iceland, its government, to decide we're going to be in zone 0 with the rest of the world. And if they decide that me as a single human being will not certainly yell at them and say, that shows you some information, I think the system comes into play. So that's where I see it going. And then in terms of adoption, this is kind of the first step. This has been working on this in stealth mode until today. Okay? All right. Okay, so any other questions before I kind of move on to the next thing? Okay, then we're good. So I showed you this, the map, and maybe the thing that I didn't exactly show so well is that this visualization is kind of cool because you can edit the table. And when you edit the table, the points update automatically. Okay? So this is a data science and data viz meetup. I think this is cool how you can pick a different projection, right? So here the one that's by default is this equirectangular projection, but we can pick a different one. Like equal Earth is kind of a mix between completely flat and something that's kind of trying to tell us that this is a round thing that we're projecting onto a scale. Okay. Another thing that's interesting on here is I can show you where the sun is currently. Like what point on the Earth is the sun currently overhead, exactly overhead. And also show you a shadow, do the shading on the world of where it currently is night. Okay. And then of course we can resize this globe to be larger and smaller. We may want it smaller so that I can also show you that we can have here a compass and a color wheel. Okay. So compass shows you a direction, compass direction. You can call it a bearing, an azimuth. There are lots of different names for it. But basically, as I move these points around, the compass turns to show us what direction we need to head in to go from the red point to the cyan point, okay, or pink to cyan. All right, and just how a compass, is a circle, a color wheel is a circle. So every point along the compass, I can also tie to a color. All right. The other data viz thing here is that I've got a slider that rotates this color wheel. That's pretty good. And then I have a color bar, or hue bar, that I can click to select the color. And there's a little preview. I say, do I want green? Yeah. I click it, and then I've selected green. Yeah, really. I mean, what are we talking about? Where we are, what time is it? Which direction we're facing? What is this color, right? What is the distance from here to here? All of that, really, all of these things that we have, including measurements of volume, we won't get into that. All of that is handled by the system, and it'll take time, but I hope to convince everyone in the world that this is better. Okay? Yeah, go ahead.
Do you have a different unit for temperature?
Oh no. I think that's such a good one. I like temperature, but I say they're kind of three that we use right now. Fahrenheit, if you know the story, was a guy measured his wife's temperature when he had a fever and said, that's going to be 100. Okay, and then later they kind of figured out what 0 should be, which is not a very scientific approach. That was Fahrenheit, right? And then Celsius is based off of when the temperature that water boils, right? Which makes a lot of sense to me. We have 0 water freezes, 100 water boils. That's at 1 atmospheric pressure, okay? Now, there's also Kelvin, which is how scientists do it. Oh, we like to add 273 to everything. Yeah, it's okay. Why? Because of absolute 0. I think both Celsius and Kelvin are scientific and are great. If you're used to temperatures being 1 or 2 digits, Kelvin is not the right choice. But it's also a fine one where it's clearly defined where water boils and where water freezes, right? It happens to be that water freezes at 273 in Kelvin and boils at 373. I think that's fine if we want it, but Celsius is a perfectly fine way. So that's one of the few things that I'm not endeavoring to change. Yeah?
Well, I found Kelvin to be very useful in explaining high temperatures like superconductivity to my father-in-law.
Yeah.
And it has a lot of uses. You look at astronomical objects, there isn't going to be much difference between Celsius and Kelvin.
Sure, sure. If you're thinking of like the temperature of the sun, you won't notice the difference in the numbers. Yeah. But for us, you know, on planet Earth, Celsius works pretty well. But if you like Fahrenheit, you know, another discussion we can have during data drinks. Yeah? I'm gonna basically kind of show you the end of the presentation, and then we can continue the conversation either here or in data drinks. We'll kind of get a feel for the room. Okay. So I just showed you one of the Viz and Tell things that I prepared. I showed you a couple of the props. I didn't explain this thing, which is you can use your fingers to translate a month and a day of the month into a day of the year. Okay, that's pretty cool. But again, we'll save that for data drinks. You know, after a couple drinks, I'll teach everyone to do this calculation on your fingers. Okay, and I passed around the Vitruvian Man and kind of showed you that distance measurements, if it relates somehow to the human body in a way that's understandable, then that's great. Showed you globe. I haven't shown you the paper airplane, which is another good one. Okay. This system can also handle. I guess you got to move the camera. This system can also handle movement in 3 dimensions. Okay. Has anyone flown a plane before? No one. Me neither. Okay, so we're in the same boat. Good. So there are basically 3 axes of movement. We're all familiar that we're in a 3-dimensional world, right? When a plane turns, it's not going to be able to turn exactly like this, right? A drone could, but that's called yaw, Y-A-W. I didn't come up with this name. That's actually what it's called. Okay. When and up, that's pitch. Okay. All right. And when we roll like this, what's that called? It's called roll. That's right, exactly. So we've got our 3 dimensions, right, of movement. Yeah. So in this system, we would just say a full turn, full spin of yaw is 1 spin, and we measure it in millispins or decispins or whatever, you know, metric prefix we want to put in there, right? But a millispin is 1,000th of a spin, right? A milli flip is 1,000th of a flip, so that's pitch, okay? And then a milli roll is 1,000th of a roll, okay? Yeah.
You know, this system of reckoning degrees reminds me of a now obsolete system that used to be used in engineering, grads.
Yeah.
400 grads in a circle.
Exactly. So that's people saying we like degrees, but it's a little bit weird for it to be 360. Let's round it up to 400. And I say, great, let's keep rounding. So let's go past 400, past 500, up to 1,000. Yeah, and round. It's a ceiling function. Okay, it's a ceiling function. That's what it is. Okay. So basically, that's what it is. We have 1,000. We could call them grads. I think it's nice to have specific names. So spins, flips, and then rolls. Okay. All right. That was my last prop. Very good. Oh no, not my last prop.
Well, what happens when you change the coordinate system?
So see, my wife prepared this, except for these sloppily drawn things in the middle. Of course, I do that. But this was supposed to be the start time, 9:75. Okay. There's a meme, you may have heard about it, is how someone explains a clock to someone else who's never heard of a clock, right? And he says, okay, well, we start at 12. What, 12? We start at 12? It's like, yeah, we start at 12. So, okay. And then we've got a big hand and a little hand, okay? And then the little hand doesn't show the number that's on here. What it does is it shows it times 5, okay? Cool, all right? And then when it's down here, that's 30, and that's halfway through the big one, right? And it's this meme of like someone getting like extremely confused because that is bonkers. That's just completely mad, right? So the big hand shows you the actual number, right? And the long hand, right, that one shows you it basically times 100. So it's supposed to be easier, right? If you disagree, that's fine. I think it's simpler than saying the big hand divides the day into 24 pieces, and the little hand, how many minutes there are in a day? Yeah, 1,440. Okay, so I think it's a lot easier to just say, okay, there are 10 decidae in a day, and 1,000 millidae in a day. Right? Okay, this was my last problem. Does anyone have a question? You had a question, yeah?
Is there a second hand on the clock?
Yeah, I didn't draw that, but it would be maybe like a long red one, depending on what clock format you had. Those would be beats, yeah, and those would go around. You know, you have 100 beats, gives you a milliday, right? 100 milliday gives you a deciday, and then 10 deciday, that's a day. Okay. All right. Okay, we're done with props. There's my little Vitruvian man with a censored. I don't know. I think it actually looks more obscene. We did the demo, we did the toast. We did questions. Okay. Now I'm going to ask for kind of feel out the room a little bit, right? Because it's almost, it's kind of late. If there's interest in a Viz and Tell, right, like additional Viz and Tell, I can show you basically this calendar plot in action. I can show you also a daylight plot, which shows you how much daylight there is throughout the year. Okay? And I can show you a couple other more interesting miscellaneous fun things, but only if there's kind of like an appetite for that, right? We could do questions, like any other questions if there are. We could do community announcements, and we could also, we'll definitely, yeah. And we could also just head over to Data Drinks now, and then you can ask me your questions over a beer, right? This is kind of, there's like a democracy where the people decide, and then there's a what I call a shoutocracy, which is whoever just yells out the first thing that comes to their mind. Is there an interest in the room generally to, should we do community announcements now?
Yeah,
Let's do community announcements now, and then if there's an appetite for further Viz and Tell, we can do that. Okay. So I'm gonna run this. Does anyone have any announcements? Community announcements. Okay. For events, things that are coming up, things to look forward to. Yeah. Go ahead, Jeff.
Women, gender equality.
Gender, expansive
Expensive
coexistence.
around the X. There's a meetup on Tuesday. It's right here. Come to it.
Yeah.
That's thing one. Thing two, Prefect is hiring for a couple of sales engineer roles. Go to prefect.io and check that out if you're interested. And I think that's all for right now.
Cool. Awesome. And if you're interested in working at Prefect, you know who to talk to. Yeah. At Data Drinks, yeah. Any others? Alex.
So March 18th, we're going to have Data Viz DC. We just got our speaker all cornered in with kind of how to use data visualizations to do data storytelling and presentation skills. It'll be Benji Braun, who's a local
Data Viz guru.
Yeah.
Yeah.
That's the right word.
That's what.
Yeah, so that'll probably be at Excella. We're still getting scheduling up, so watch meetup.
March 18th.
March 18th.
Data Viz DC. Okay, cool. All right. Any other events? Anyone, looking for jobs or anyone hiring? If not, we'll chat about it at Data Drinks. Okay. Cool. All right. Now, temperature in the room for showing you maybe calendar plot in action, interactive Viz, and then a daylight plot. People still interested? I promise it won't take too long. Okay. This is all of these visualizations that I'm showing. These are with Observable, right? So the system created by Mike Bostock. The calendar plot is kind of a set thing that Observable created, and then I, had to change it quite extensively to make it be the way that I liked. Yeah. So your regular old calendar that everyone is used to, right, is based off of weeks and days of the week. Those are the axes. So here we have weeks, and they can go up to 52 if you start at 0, right? And then you've got days of the week, that's on our y-axis. And then the color labeling, that's months. Okay. Up here, this is the Dec calendar or the calendar, right? And it's also split up by months, but that's if you like, but it's not necessary. Okay. Instead of weeks or months, we have decs, so groups of 10 days, and we have days of the Dec. Okay. And I'll show you in a second exactly how does it work. What days would you go to work? What days would you rest? Spend time with your family and so on. Right? I'll show you that in a second. For now, for this one, I'll show you how right now in time zone 0, we're at day 0. Okay? First day of the year. That translates to the Gregorian calendar as March 1st. Okay? And it's always March 1st, every single year, common, leap, doesn't matter. Okay? And then I can show you how I can move this thing around and select a different day of the year. Okay? As I move these two sliders, it shows me a different month and day of the month. Where I kind of ended randomly was day 280. Okay? Day 280 is December 6th. I know you're kind of uncomfortable with this thing of everything also has a negative version, but day 280 in this year can also be day minus 85. Tells you how many days there are left in the current year. Okay? It's always, so if you have a birthday, don't tell me your birthday. That's PII, and I don't want to know. But if you have a birthday, everyone has a birthday. You can translate it from a month and a day of the month into a day of the year. Okay? Now there's one number that represents your birthday. Or if you say day of the year, it's your birth, I guess, doi, right? Instead of your birthday. This plot also, we can add on a leap year. Okay? And here in the calendar, there's not much of a change. You add a day at the end. Now there are 366 days. The last day is day 365 because we start at 0. Here at the bottom, when you add a leap year or take it away, you can see all those numbers are changing, right? It's a huge disruption. You're putting a day kind of at the beginning, but not at the exact beginning, and it shifts everything down. And that's what ruins ordinal days in the Gregorian calendar. Okay? All right, there's also an animation where we can just let it go and have it play. Okay? So these sliders, it's an interface that makes sense, I think, to people. You can use this to convert between day of the year and month and day of the month. Okay? All right. So down here at the bottom, it's also, you can change the first day of the Gregorian calendar year, right? So have it start on a Sunday, have it start on a Thursday. And you can see this also shifts all the days kind of crazily, but the calendar doesn't change. Down here, this is an annual calendar. You throw it out at the end of every year. Why? Because you're not going to hold on to it for 14 years until it becomes valid again. Okay? It's not always 14. Sometimes it's less, sometimes it's more, right? Here, this is the calendar every single year. It's perennial, meaning for every year. You have a question?
Assuming people still come up with some Dec schedule similar to our week.
Yeah, yeah.
At the end of the year, go from midweek or mid-Dec to beginning of Dec?
Yes, you do, but it's actually a smooth transition. Okay, and I'll explain that right now. Okay, so in addition to observable, I also use Mermaid for flowcharts. Okay, up here, this is the zero-based reckoning for the days of the Dec. Okay, down here, this is the one-based reckoning, and believe it or not, both work, and you're free to think of it whichever way you like. Okay. When we get to the end of a common year, okay, we're at day 364. which is day of the Dec 4. Okay? We would normally continue on to day 5. But instead, we flip over to day 0, which is fine. Both are rest days. Okay? So the last day of a common year and the first day of any year are both rest days. Okay? So instead of just going, let's say you reach the end of this row and you start at the beginning of the next row, you just start at the beginning of catastrophe. And we need all hands on deck. We need everyone to work. Maybe we'll work 4 days in a half deck, right? All those schedules are defined, and there's a hybrid one where we work 3 in the first half and 4 in the next half. And that gives us more or less the same number of work days as we do with our weekly schedule. 9 to 5, 5 work days, 2 rest days. It gives us more or less the same number of work days. Yeah? Yes.
Since there have been proposals for a 4-day work week,
yeah,
be nice. How closely would this align with a 4-day work week?
Right. So this is actually analogous to a 4-day work week, right? And if we add on a day, that's analogous to a 5-day work week. Yeah. Yeah. Simple answer. Yeah. Okay. The stick shift analogy. Here's my stick shift image. This is all on my website. And then I wanted to show you this thing about hands, right? Because days of the month are 1-based and days of the year in des are 0-based. We've got this little thing of like, to find out what day in March it is, we have to use -1. Okay, so there's a little bit of misalignment. But today is March 1st, let's say, in zone 0. Okay? And then we take that 1 and we add it to -1. We have day 0. Okay? So for this, how does it work? Is when you want to translate it, you find a month, you get the, that month basically translates to this number of days in the day of the year. Okay? So October 1st is going to be 214. You basically take the day of the month and you add it to this number. Okay? And so you can, think about what's a day that matters to you, a birthday, an anniversary, right? I'm looking at my wife here, and I'm like, there's a clear one, right? That we use. I'm not going to tell you because we use it for like passwords and combinations and things like that, right? But you can think about what is a number, what is a date that matters to you, and this system, which is very natural, based off of our 10 fingers, in order to fit 12 months onto 10 fingers. Pinkies have to represent 2 months, March and April, and January and February. But it works, really well. Okay. I want to be clear. If you're just using des, you don't have to finger count. If you're just using the Gregorian calendar, you don't have to finger count. Okay. So it's only just a quick way to calculate between the two systems. But ideally, people will just be comfortably using whatever system they prefer. Right? And when there's a need to translate between them, it's possible. Computers can do it for us, ideally, but if we're in the middle of the woods and immediately have to know what our birthday is in both systems, then we can count it on our fingers. Okay?
FYI, your Mac is low battery.
Yeah, you can tell I'm nervous because it's like, it's time. We're at 8%.
It's the moment.
Yeah. Let's do one more Viz. And then we'll be done. Okay, and we'll head to data drinks. We'll head to tonic for data drinks. So this is time, and I feel like I have to really apologize because one of these things, if you're unfamiliar with, or if you're uncomfortable with things being negative, this will really make you uncomfortable. We have, and I apologize, we have time that goes plus, and it goes clockwise, and we've got time that's negative, and it goes counterclockwise, okay? So this is controversial, but in the northern hemisphere, so that's why clockwise is clockwise, okay? But in the southern hemisphere are some that would go in this direction. Okay, counterclockwise. Right? We've got positive time and we've got negative time. Okay? And then down here we have positive and negative time as a bar chart. Yeah? Oh, data visualization. Okay? Down here I have a map, and the map is connected to this plot down here. So when I move the cursor, the globe rotates, and this daylight plot moves as well, changes shape. Okay? So it will tell us, depending on the day of the year, how much daylight we have. When we have a very wide point in the plot, the daylight is very long. Okay? The amount of daylight is very long. Okay? And so if we go to certain parts that are very high up in latitude or very low in latitude, right? There will be times when it's always night, and there will be times when it's always day, right? And that's what this shows. The other thing is, on here, on this daylight plot, I can move this line, and it'll rotate the globe, and I can move this dot, and it'll, the line, which I'm having trouble moving right now, but the position of the world around the sun. Okay. All right. Stealth mode for 2 years or plus, and you can tell very passionate about it. I love teaching, and this was me sharing something that I think is really cool. So hopefully, if you know that meme where someone says like, "Here, I made this," and the person's thinking about it, they're holding it and they're thinking like, no, I made this, right? Feel free to take this as your own and think of other ways we could do this. Use this wherever you like, wherever you think it's useful. I want to end on 2 jokes, okay? So one, I woke up this morning with a swollen eye. Who knows what that's about? But if you've been wondering what this is about, it's a random thing. But the standard joke for this is, you think this is bad? You should see the other guy, right? And then the other joke is, a guy and a girl are talking, and they're talking about, what's your idea of an ideal date, right? Is it, candlelit dinner, walk on the beach, or is it year, month, day? For me, it's year plus day. Okay? I think that's it. Thank you so much, everyone.
I'll say this is super impressive, and I'm honored that you introduced this here at Data Science / Data Viz DC. So thank you everyone for coming. Please feel free to eat some more food, take some more to drink, and then in a few minutes we will have to get out of the space, and people will go to Tonic, which is down the road, and you can continue the conversation there. Have a great weekend.